In this lab, we performed tensile tests for 3 materials: 6061 aluminum, grade 2 titanium, and 4140 steel. The machine used to test the materials was an MET-ENG-3125 universal testing machine paired with an MTS-LX laser extensometer. A sample of each material adhering to the dimensions of the ASTM E8 standard was provided. Each sample was made with a slight taper, creating a failure point in the center of the sample without significantly affecting results. The diameter of the samples at the center were measured with digital calipers. A piece of reflective tape was placed an inch away from the center on both sides of each sample. The pieces of tape served as markers for the laser extensometer to measure the change in length of the specimen during the test. A sample was placed in the grips of the machine. The laser extensometer was lined up so that it was centered on the sample and read approximately 2 inches. Some parameters were set up in the MTS program. Due to some technical difficulties, our steel sample was left trapped in the machine for an extended period of time. Once resolved, the sample was slightly pre-tensioned by manually controlling the machine with the program. The machine is started. After the specimen fractures, the machine is stopped and the pieces of the sample are removed from the grips. The machine pulls the sample apart at a constant rate while measuring the elongation and the force required to keep pulling.
Here we can see the engineering stress versus strain graph. We can see that the steel has the highest engineering stress and the shortest amount of strain. This is because steel is a very hard and strong material, and it has a very low elasticity, which leads to very early fracture. The titanium has the most engineering strain that occurs to it, while having moderate engineering stress. Titanium has a higher elasticity than both aluminum and steel. And finally, with the aluminum, we can see that it has the lowest stress, meaning that it can absorb the lowest amount of force. We also see that it has the lowest strain, and this is because aluminum is the softest material out of the 3 that we tested. Here we can see the properties of the 6061 aluminum, 4140 steel, and grade 2 titanium specimen that we tested. We see that the 4140 steel has the highest yield strength and ultimate tensile strength of the 3 materials, while 6061 aluminum has the lowest yield strength and ultimate tensile strength. We see that the grade 2 titanium has the highest percent elongation, while steel has the lowest. For the reduction of area, we see that the aluminum actually has the highest reduction of area, with the 4140 steel having the lowest of the 3 materials. Finally, with the modulus of elasticity, we see that the grade 2 titanium has the highest, while aluminum has the lowest. Here we can see the mechanical properties for 6061 aluminum, 4140 steel, and grade 2 titanium. The yield strengths of the material for the 6061 aluminum and 4140 steel were similar to the standards which we found. The grade 2 titanium exemplified lower yield strength along with ultimate tensile strength compared to the standard. Similarly, it had a much greater area of reduction and percent elongation to the standards. The aluminum exemplified slightly higher percent elongation, while the 4140 steel exemplified lower percent elongation than their respective standards. And finally, there was a much greater area reduction for the aluminum than the standard, while the steel was moderately under for its standard.